Hey guys, and welcome back. Today what we're going to be talking about is something known as binomial nomenclature. Now, to pick up where we left off yesterday discussing this whole system of classification, this hierarchy, you could say, from the broadest being now domain to the most specific being species. And before we left off in the video, I mentioned how you could remember the order of classification with the mnemonic device King Philip came over for good spaghetti. Or if you're thinking about domain, you could add did and make it a question. Did King Philip come over for good spaghetti? And that just helps you remember the order of classification. So domain, kingdom, phylum, class, order, family, genus, species. Now, see this we had that little asterisk beside the genus and the species name. And that's because these two sections of our classification are what are going to help us with developing what's known as binomial nomenclature. And we're going to get to that in a second. First, I want to talk about today's Bellwork question. And so today I asked you to describe a buffalo, specifically what that buffalo might look like and where he might live. And in most cases, you were probably thinking of the American buffalo living out west in the prairies or something like that. But then again, you might not have been. Maybe you were thinking of this. This is an Asian water buffalo. Or maybe you were thinking of this. This is known as the Cape buffalo or the African water buffalo. And if you were like me when you hear the word buffalo, you're probably more so thinking about this, the American bison. Now again, the reason I say you could have been thinking about all three of these different animals is because each one of these animals is commonly referred to as a buffalo. And so if I'm talking to somebody, let's say about a buffalo, and that person is from let's just say they're from Malaysia, all right? And I mention a buffalo to somebody from Malaysia, they are not going to picture this in their head. They're going to think I'm talking most likely about something like this. As you can clearly see, it's a totally different animal. And so that's why sometimes we have these problems with things known as common names. In other words, the term buffalo. Each one of these actually has its own scientific name using binomial nomenclature. And so we're going to look at what that is today, what specifically binomial nomenclature is. So again, this guy's going to have a unique name, this guy's going to have a unique name, and this guy's going to have a unique name. That way, no matter what culture or country you're talking to somebody about something from, they're going to understand that when you say bison, bison, oh, he's not talking about this. When he says bison, bison, he's talking about this. And again, just like our modern classification system, who do we have to thank for this simple scientific naming system is none other but the father of modern taxonomy, Carl Linnaeus. And so, again, in this book, System Natura, when he was first going through and making this classification system, he came up with the idea of genus and species, with species being the most specific. And when you would take the genus and the species together, that would be what you considered its scientific name. For example, I told you guys we talked about this guy today. This is a tokay gecko, and that's what we call them. That's its common name, because its call, when it actually makes a call, it sounds like it's saying tokay, tokay, and so it's called the tokay gecko. But when Carl Linnaeus first saw it in the 1700s, he just simply called it gecko gecko. It was from the genus gecko, and it was the species known as gecko, which means that every other gecko that you see, like the little crested geckos we have in the classroom, their species is not gecko. In fact, they're not even in the same genus gecko, but that's a different story. And so again, he came up with the classification system, going from broad to more specific, and those most specific ones are the species, and every single species is going to be unique. So let's see what I mean by that. All right, so the species name itself is only going to be given to an individual type of organism. In other words, only wolves are going to be considered the species Lupus, specifically the gray wolf. There are several different subspecies or just species of wolves, but when we say Canis Lupus, if you're talking to a biologist, they're most likely automatically going to know, oh, he's talking about the gray wolf. All right? And so again, just like all of our other classification systems, species are based off their morphology and other characteristics, how they look like. But again, if they are going to be the same species, the morphology, how they look, their characteristics need to be more similar than any other classification. And so again, we look at our classification and we can see that within the Canis genus, you have the wolf, you also have the dog, you have coyotes, and you have your other feral or wild dogs. But notice, they are, as similar as they are, they're also unique and different. For example, you can see the body structure of a dog and see how it's similar to a wolf, or even a coyote. However, you can still tell that they're unique. They're different from each other. And so, every time you see a wolf, though, you're going to know that's a wolf. And so then they would have their own species, which is what we see down here, known as lupus. And so going back here, again, the other important thing about species, and I want you to highlight this, underline it, circle it, whatever you need to do in your notes, because this is what, this is our best definition of what defines something as a unique species, is if those species can breed and have viable offsprings. All right? So, the technical definition, there's several different definitions, but the one that we're sticking with for this class is that if it can breed, in other words, if you could have a wolf and a wolf from, let's say if you had a wolf from North America breed with a wolf from Europe and they had pups, and then those pups were able to reproduce and have pups of their own, that would mean that the North American wolf and the European wolf were the same species. And so that's what it means by viable offsprings, is if they can, those babies that they have can reproduce. And so, for example, you may have wolves and maybe they can reproduce with a coyote. However, some people might look at that with what that does happen from time to time. They're known as a Kai wolf when that happens, but it's what's known as a hybrid. And generally, your hybrids are not going to be viable. They're going to be sterile. In other words, they can't reproduce on their own. Now, in the case of a Kai wolf, we have seen that sometimes they can reproduce. And even with ligers, we have recently discovered that a liger, which is a hybrid between a lion and a tiger, when you breed those two together, when you breed the lion and the tiger together to get the liger, it should be a sterile animal. In other words, it shouldn't be able to reproduce because it comes from two different species. However, when you take a male lion and breed that male lion with a liger, they actually can reproduce, and it's what's known as a liger then. All right, so as you can see, and this is what we're going to be talking about a little bit next week as well, our definition of a species, the ability to breed and make viable offsprings, that's still a little tricky. And so the whole idea of defining what makes up a species can be kind of tricky from time to time. However, for right now, you just need to know that if it can reproduce and have babies that can then have babies, they're most likely the same species. And so again, when we define a species, that species name is going to be unique to that species and that species alone. So we have Canis Lupus, all right, which means that you are not going to find another organism within the Canis genus that will have the species name Lupus. So looking right here, we have our wolf, which would be Canis Lupus. This guy would most likely be, I believe it's Canis familiaris or domesticus, one of the two. That's the dog. All right. Familiaris is going to be his species name, so on and so forth. And when we talk about this, now notice again, I say Canis lupus when I'm talking about him. Lupus was the species, but what's Canis? All right. If you look right up here to the genus, you see that Canis is actually the genus name. And so Canis lupus, he has two names, and that is his unique scientific name. So if you've ever heard me in class refer to an animal and say their scientific name is this, or you might have seen it somewhere before where somebody says, what's the scientific name? That's what they're referring to. All right. So that's what's known as binomial nomenclature. Nomenclature is simply naming something. Bi meaning two, nomial referring to name. It literally means to name naming. All right. And this again was developed by Carl Linnaeus when he was coming up with this classification system. He said, let's take the genus and the species name and let's just make that the organism's specific name. Because if you watch that crash course video I sent you guys the link to yesterday, or was in the link for the YouTube video, you saw that it was talking about when Carl Linnaeus came on the scene, the scientific name of the tomato was about 17 names long. And you had to write out all 17 names just to know that somebody was specifically talking about a tomato. He said, no, that's crazy. We don't need that. We need to simplify this. And so he did. And he simply came down from 17 names to 2. And so again, the example that we've been using is for the wolf. And so the wolf's genus is Canis, the wolf species is Lupus. Another way that you can think of this is like your name. We have binomial nomenclature. Some of us maybe even trinomial, where we have a middle name. But when we talk about that, for example, my name is Eric Eversole. Eric is my first name, Eversole is my last name. All right? And when we're talking about binomial nomenclature or scientific names of animals, if Eric Eversole was my scientific name, Eversole would be my genus. But I'm unique, I'm the only Eric in my family, so that's my species name. So do you notice that? Like our family name can have a bunch of people in it. So there can be a lot of Eversoles, but they're all uniquely Eversoles. So they're the genus Eversole. But then there's the species Eric. All right. So that's just another analogy to think about it. But genus is going to be the broader one. You can have several different species within a genus, but then when we talk about the species, we're just talking about one specific organism. And so let's say that you discovered a new animal or a new plant or even a new virus. Even though viruses don't fit the exact mold for something that's considered alive, we still use this idea of hierarchical structure for naming viruses as well. For example, the coronavirus is a family of viruses. All right. But again, let's assume that you go down to the Amazon rainforest and you discover a new species of frog. If you want to name that frog after your mom or your favorite movie star, you can do that as long as you follow some specific rules when you're naming this organism. And the most important one is it's always going to be in Latin. And generally that Latin will help describe either where it's from or some characteristics about it. But if you just want to name it after some random fictional character, you can do that too. And so we're going to go through the rules of naming, and those are going to be the last things on our notes today. So, the rules of binomial nomenclature. Number 1, the genus species name must be used. In other words, for the scientific name, has to be the genus first and then the species second. That's how you write it out as well. Number 2, the names must be in Latin. Number 3, the entire name must either be underlined or italicized when it's written, but never both. In other words, when you see Canis Lupus, if you noticed on some of them, I think it might have actually been incorrect on one of our slides, the name should be italicized. In other words, it should be slanted when it's written. And if it's not, like let's say you're just writing it out by hand and you really can't italicize your handwriting, you just underline the name, and that works. Right, number 4, only the genus name is capitalized. And this is very important again. It's just like a grammatic rule of science, but for whatever reason, only the genus name is what's going to be capitalized. So like you see here where I have genus, species, that's how it would be written out. The name must be applied to the organism from 1753 to now. In other words, if an organism had a scientific name before 1753, that scientific name gets thrown out and it's no longer used, and so we have to come up with a new one for it. Why 1753? Because that was the year that Carl Linnaeus published his book on binomial nomenclature. And so he was the one that came up with it, and so everything before that basically got thrown out the window. Alright, up next, the first appearance of the name must be in a scientific journal with a description of the animal or organism. Alright, in other words, there are these journals, and I'm not talking about like Dear Diary or like a journal that you write in each day. Scientific journals are where scientists will publish papers that they have written about their research. It's what's known as peer-reviewed journal articles. And in these journal articles is where people publish these discoveries for the first time. And then later on you'll see articles about scientists discovered this. Well, scientists just didn't come out and say they discovered it. It took them probably at least 7 years to come to these conclusions and find these things and come to the point where they say, okay, we can publish this as a paper. And you had, for example, you had a problem with this when the dinosaur craze I know it's weird to think of a dinosaur craze, but in the 1800s you had what was known as like these bone wars, and you had these scientists fighting and scrambling to try and describe dinosaurs before somebody else. That way they could claim credit for it. And Tyrannosaurus rex was actually one of these dinosaurs. Again, Tyrannosaurus rex, that's the dinosaur's actual scientific name. But Tyrannosaurus rex was discovered by several different people, and when one guy went to go publish his findings about Tyrannosaurus rex, and he was actually he had some other name for it, I forget what the name was, but when he went to go publish his findings, he realized that somebody had already beat him to it. And the animal that he was describing was exactly the same as the animal that was being described in some other scientific journal as Tyrannosaurus rex. And so the name Tyrannosaurus rex took precedence as a scientific name. And again, the name must not be a duplicate of a previous name. And so let's stick with our dinosaur example for now. Let's say I discover a new species of raptor, all right? And I want to name this raptor Tyrannosaurus rex, Tyrant Lizard King. Well, if nobody has already named it that yet, I can do that, no problem. However, if I go back through and I look through the scientific journals and I see, oh, somebody already named an animal Tyrannosaurus rex, then I can't do it. And then last but not least, the first name that's proposed with all those, that follows all these rules will be the one that is then selected for that organism. So again, if you follow these rules when you discover an animal, or when you think you've discovered an animal, or an organism, as long as you're the first one to do it, you can name it whatever you want. And so to end today, I have a fun little video for you guys to look at. The link for this is going to be in the description, but it's simply titled 10 Ridiculous Scientific Names. And it's like a top 10 of all these weird different animals that were named either based off of movie characters, book characters, actors, singers, and how sometimes they even fit the scientific classification as well. But again, there's real scientific names. There's one about a bee, or not a bee, but a fly being named after Beyonce. This weird type of scorpion thing is named after Edward Scissorhands. And so the video kind of talks about that and the scientific logic and reasoning behind that. And so, again, I would just suggest that you guys end today watching this little video, and I will talk to you guys later.